Hello, today I'll be discussing my project on Profit, a time series forecasting model developed by Facebook. Time series forecasting simply means predicting the future by learning from patterns in past data. Profit is designed exactly for that. And what makes it special is that it handles real world challenges like missing data, sudden trend changes, and irregular patterns very well. Now let's see how Profit actually works. For this, let me first show you that this is the time series dataset I used, and this is how Profit broke it down. This is because at its core, Profit treats every time series as an additive model. That means it assumes that the overall data pattern is made up of several smaller components that, when added together, explain the full behavior of the series. These components are trend, seasonality, holidays, and noise. Now let's go through them one by one. The trend shows the long-term direction of the data, whether it's rising, falling, or staying flat. Profit models this trend using two main approaches: piecewise linear and logistic growth curves. A piecewise linear trend feeds the data with several straight line segments. These lines can change slope at specific points called change points, allowing Profit to capture sudden shifts, like a company is suddenly speeding up or slowing down in growth. Profit automatically detects these change points from the data. Meanwhile, logistic growth represents situations where growth starts fast, then slows down, and finally levels off at a maximum limit, like population growth or product adoption. Next comes seasonality, which captures repeating patterns like daily, weekly, or yearly cycles. Profit models this using a mathematical tool called the Fourier series. In simple terms, the Fourier series breaks down complex repeating patterns into a mix of smooth sine and cosine waves. Each wave represents a small part of the seasonal behavior, and then when combined, they recreate realistic seasonal fluctuations, such as weekly sales spikes or yearly demand cycles. And then there are holidays, which represent sudden one-time events that cause sharp changes, for example, Eid, Christmas, or Black Friday. These events can cause temporary jumps or drops in the data. Profit allows us to manually include such special dates so that it can make more accurate predictions around them. Finally, there's noise, the random ups and downs that can't be explained by any consistent pattern. Profit accepts that randomness exists and tries not to overfit it. This keeps its prediction realistic and stable. Now let's come to the dataset I used. I worked with Adobe's historical stock prices from 1986 to 2022. However, I only kept data from 2014 to 2019 because earlier data was mostly flat and had little predictive value, and the data from the COVID period after 2020 brought extreme volatility that could distort the results. During pre-processing, I checked for missing or duplicate dates. Then I converted the data into Profit's required format. Profit requires only two columns, the date column named DS and the target column, which in this case is the adjusted close price named Y. Then I also applied a log transformation to stabilize the large fluctuations in price which are usually seen in stock data. Then I ran a pair plot analysis to check relationships between variables. It showed that almost everything except trading volume was highly correlated, which makes sense for stock data. There was also a small visible gap around 2017, which was caused by a price jump when Adobe launched its Experience Cloud. Next, I tuned Profit to perform well on this dataset. I used Profit's built-in cross-validation with a 60-day horizon to train and validate the model. I allowed higher flexibility for trend detection but kept seasonality conservative to avoid overfitting. I included weekly, yearly, and quarterly seasonality since stock prices often follow these cycles. And I turned off daily seasonality since I didn't have any hourly data. I also used a higher confidence interval and uncertainty samples to make the results more stable. Now let's look at the results. The model achieved a strong R-square value of about 93.5%, showing it captured most of the variation in data quite well. Both the mean absolute error and root mean square error were moderate. The slightly higher root mean square error indicates that the model performed worst on some particular days, likely due to market news or earnings reports that weren't included in my holidays list. My holiday list only included the US holidays. The low mean absolute percentage error suggested that the model was generally robust. However, I noticed the coverage was lower than expected for the uncertainty interval, and the average width was narrow. This meant the model was a bit overconfident. Then I tested the model on 2019's data across multiple forecast horizons. To evaluate Prophet's performance, I compared it against a static persistence model, also known as a naive model. This baseline assumes that the last observed value, which is the first value in the test set in this scenario, stays constant in the future. A simple but strong benchmark to check if Prophet is truly learning meaningful patterns. Prophet consistently outperformed this baseline across all metrics, showing much higher accuracy. However, as the forecast horizon increased, meaning the model predicted further into the future, the uncertainty intervals widened, which is expected since future predictions naturally become less certain. I also experimented with models that included external regressors like price related indicators, but they performed poorly because the regressors were highly correlated with each other. This led to the multicollinearity problem. To sum it up, Profit is a powerful and user friendly forecasting tool, especially for data with clear trends and seasonality. It's not always ideal for stock prices since financial data like stock prices is highly noisy and often follows a random walk, and it's also highly correlated to yesterday's price alone. But Profit still provides valuable insights. That's why it's widely used for business forecasting, like predicting sales or demand, where its interpretability and ease of tuning makes it extremely useful. Thank you. You can find my notebook at the link below.